In this video, we will handle Pillar 3 for equipment reliability. So in Pillar 1, we have talked about the value that should be delivered to the organization, and we have a specific manufacturing process in Pillar 2 in order to deliver this value. So this manufacturing process will be composed of a set of equipment like motors, compressor, pumps, fans, transmitters, in order to operate together to deliver this value to the organization. So we should be aware about the design, selection, installation, and operation in terms of the maintenance strategies to be applied for these equipment in order to ensure that we already have the required reliability built in them. So for this pillar, we have 7 sections. We have a lot of knowledge areas to be studied in this pillar, and we have many references to be recommended. The most important one is Maintenance and Reliability Best Practices by Ramesh Gulati, and for sure, if you are taking our detailed course, you will not require any extra readings for passing the real exam. First section is about the determination of equipment reliability expectation. So we have here 3 very important terminologies. You can refer to them in the foundation video about the reliability concept, the maintainability concept, and the availability concept. We need to understand extra here that we have 2 kinds of assets. Either we have repairable assets or we have non-repairable asset. Non-repairable asset like lamp. If lamp failed, we will not repair it again. But here, if we have pump, we can replace the seal, the bearing, the repair kit, and restore its capacity again. So we have repairable asset and non-repairable asset. For repairable asset, we are measuring the mean time between failure with this law or by this equation. And for non-repairable equipment, we are having mean time to failure because this lamp, when failed, is already replaced, no opportunity for being repaired. Next, we have maintainability, which is measured to the easiness of maintenance, which is mean time to repair, and mean time to repair, the lower, the better. This is opposite to mean time between failure, which is higher, the better. Then we have availability, which is a function of both the maintainability and reliability, and it is equal to mean time between failure upon mean time between failure plus mean time to repair, or uptime divided upon uptime plus downtime. And availability, the more availability that you are having, the more productivity that you are having, and then the more value that you are delivering to your organization. After that, we have exponential equations that can be used in order to measure your reliability, and also it can be also taken in the next section for evaluating reliability. This exponential equation is very simple, and you can expect questions about it in the real exam. This is very simple equation. For example, if you need to measure your reliability to operate for 90 hours, to have a pump running for 90 hours, for example. So you will have T as 90 hours, then you will substitute for it here, 90 hours. If you have your mean time between failure as 1000 hours, so you can calculate it through the calculator and you will get your reliability, and you will identify what is your reliability exactly. Also, mean time between failure, it is the reciprocal of failure rate, which is lambda. So mean time between failure equal 1 upon lambda, which is called the reciprocal, and also failure rate can be considered the reciprocal of mean time between failure, and typically this is common questions in the real exam. Next section is to evaluate our equipment reliability. So first concept to know here is that our reliability of failure, our reliability plus our failure at any time will be equivalent. So if we have 10 lamps, so at any time the number of lamps will be 10. So if we have 10 lamps working, we will have 0 fail. Then if we have reliable or remaining lamps working like 9, we only will have 1 fail. After that, if we have only 1 reliable lamp, then we have 9 fail. So all the time the reliability function plus the failure function will be equivalent to 1, and this is clue to understanding the Weibull concept, for example. Then we have something called failure pattern. Failure pattern is if you are taking statistics for the number of failure for a specific group of assets, what will be the failure like. So if you have 10,000 pump, for example, you will draw their failures with in relative to their time, then you will have such curve. So some of the failures will taking this. They are having infant mortality, very high failure rate, then decreased, then constant failure rate, then wear out or end of life pattern. Sometime you are taking constant failure rate, then increasing. After that, you may have increasing all the time, or you have just infant mortality, then decreasing. And like this, the most famous one is bathtub curve because it represents the three region, which is infant mortality, constant failure rate, and wear out. While the most famous one or the most representative one is the infant mortality. From this classification or from this study, we have 89% as random failure and 11% as age related, which is mean that PM should be less than 20% and PDM or condition monitoring should be more than 90 or 80%. Also, this can be represented by Weibull equation. This is Weibull equation. It is a development by Waludi Maipol to the Weibull, which is a very famous statistician for the exponential distribution. Here he has added the shape factor and the characteristic life factor. And then if you are taking beta to equal 1, it will be like the exponential distribution, which is like minus t upon mean time between failure, and mean time between failure in this case will be eta, and this is the shape of Weibull plot. You are having a line which is parallel to beta, and you are taking the point of 63% of equipment failed or unreliability, then you are crossing this line, then you go horizontally to get eta, then you can represent your system reliability, and then you can draw the failure rate and to know the shape of your failure, whether it's decreasing as infant mortality constant or increasing. This is also something used during the design called reliability growth model. This is just drawing the cumulative mean time between failure for any enhancement or improvement on your design, and then you are drawing it with time to show the improvement in your design. This is called two types, either to be Dewan model or to be Crow-AMSA model. Next is the modeling. We have our system to be as simple as some of them are series systems and some of them are parallel system, so we can represent very complex system with only these two systems. So if you have very large plant, you can make a model for the plant, and then you can measure the reliability of the whole plant based on the reliability of its individual component with this series system and this parallel system. This is the law for calculating the reliability of series system, and this is the equation for the parallel system. For sure, from parallel system, we have two systems, either to be having active system or standby system. Active standby is slightly lower in the reliability of it than the standby because standby is slightly more higher in the reliability. Next section, it is to ensure that you are already adding a proper maintenance strategy for your equipment. This is applied for this section and next section, but this section is focusing only on your current existing equipment. Next section will be focused on the new equipment and how to select and how to design, but the concepts in this section will be applied in the next section also. So we have a lot of strategies like predictive maintenance, preventive maintenance, we have reactive maintenance, we have finding from PM and PDM, and modification maintenance. This is a new transformation of SMRP or SMRP distribution. In the past, it was only PM and CM, and there was nothing called PDM. So now we just need to understand a very important point before we go further, which is failure. Failure is the inability to lose or the inability of our equipment to deliver the function. So if the pump is already required to function at 5 cubic meter of water per hour and it only deliver 4.5 cubic meter per hour, so it's failing to perform the function. So this is very important concept to know, and we can represent this on this P2F curve. We have potential failure here and we have functional failure here. If we are down this, we are losing our function and our equipment is failed. So this is very important concept. Also, we should have some maintenance strategies or tasks or action implemented for our equipment in order to save their reliability. So we should be cost effective all the time. So we should have a decision making procedure in order to allow us to choose what is the effective strategy and what is the non-effective strategy. So in order to do that, our scale will be the cost of preventive or predictive maintenance in comparison to the cost of the failure itself. So if we are having a lamp with a cost of $1, we will not make PM worth of $2 in the form of visual inspection. So this, in this case, this will be run to fail equipment. Otherwise, on the other side, if we are having a pump of $1,000, we can make visual inspections worth $2 for this $1,000 to be saved. So this is very important way of thinking about the function. So in case of we having the cost of failure very high or higher than the cost of preventive maintenance, we will leave the equipment till it lose its function, then we will make repair or replace to restore it again, then it will lose its function, and like this. On the other hand, if we are having a preventive maintenance, we will make time-based decision to replace the equipment or the component. So sometime it may be change it before it's reaching to its functional failure point, and another time it can be changed in this time. That's why you should be flexible and you should use predictive maintenance or condition based maintenance in order to be able to deliver or to measure all the time the health and the remaining life for your equipment, and you are flexible. So if you are using predictive maintenance like this case, you are replacing here in this interval, while at almost half this interval you change it the next time. This is making you more resilient, more adaptable to the changes in your process. So the most important one, our target is to increase it, which is predictive or condition monitoring. This is very important also, which is the P to F curve. In P to F curve, we have some point called potential failure, in which preliminary detectable failure is being detected, and functional failure when we lose the function. The duration between them is called P to F interval. The P to F interval, we have also another concept called the net P to F interval, which is equal to the P to F interval minus the inspection interval. So if you are measuring your vibration every 1 month, and you have P to F interval from a specific pump as 6 months, so your net P to F interval is equal to 1 5 months. So you should take care of this all the time. Practically, you will have regular inspection interval as half or 1/3 the P to F interval. We have a lot of condition monitoring techniques that can be used, like vibration analysis, oil analysis, temperature analysis, gap analysis, like flux analysis, ultrasound analysis, and a lot of condition monitoring technique that is all based on taking specific parameter and start to measure this trending or to make trending for this parameter over the time. And when we reach to the failure value, we start to take or to plan for our corrective action and to be sure that our equipment is reliable. Next point is the reliability centered maintenance. This is the methodology to optimize our equipment. It is risk-based methodology that is focused on preserving the functions of our system, and also to prioritize our failure mode and start to select the most appropriate technique to be implemented. In this process, we have 4 principles, 7 questions, and 9 processes. So all of them will be handling the reliability centered maintenance methodology. One of the most important techniques or concepts here, it's called the risk priority number. We measure our tasks from this perspective as severity or failure mode. Sorry, we measure our failure modes on this scale: severity and consequence and occurrence and detection. So this one is taken from 1 to 10, and this from 1 to 10, and also this from 1 to 10. Then if we are having 10 for the three, this is very high RPN, so we should take a corrective action or redesign or whatever. If we have 1 in all, so it will be 1, so we should also not take action and make it run to failure, because it will be having no consequence on our business. Another thing it's called, which is called failure mode and effect analysis, or FEMIA, and also another form from it which is called FEMICA, which is the most famous one and most implemented one in the real operation business, which is the multiplication of the severity by the likelihood. It is one letter extra for FEMIA, but it's more simpler in the implementation than the FEMIA. Here in FEMICA, we do not have the detectability as part of the equation, and for sure, all the details are our detailed course. This is the P to F interval also with the effectiveness of each technique with time. And this is also another techniques used to ensure our equipment mechanical integrity, to ensure that our piping, pressure vessels, tanks, structures, heat exchangers, and everything is already operating healthy, and we are measuring a lot of parameters in order to ensure that the remaining life will make us sure that our equipment will be operating safely without having leaks from hydrocarbon, for example. This is the same as the FEMICA. We are multiplying the consequence of failure and likelihood of failure, and we are measuring it through many techniques, and then we are giving a decision regarding the remaining life of our equipment. Next part is for the new equipment. So in addition to the what have been said in section 3, we will add another thing to think about the strategic plan of our organization during the design and start to choose the parameters, the procurement, the spare strategy, the type of equipment, equipment selection, equipment installation, commissioning processes in order to deliver the requirement for our organization. So here in this, we are choosing and designing for our maintainability and designing for our reliability and availability to achieve our business mission. For sure, we should be focused on the total cost of ownership, which is already identified mainly in the design stage, and already all our decisions here will be affected here. So any design we are making here, we will gain its fruits here or its drawbacks here also. Typically, the costs of operation and maintenance period will range from 50 up to 85%. This is very important shape of the bathtub curve. This is just to identify to you that we have something called design for X. Design for X is to design, for example, for reliability, for availability, for manageability, for maintainability. Based on your design for X here, you will have a specific failure rate pattern or failure pattern or hazard rate here in your operation stage, which will be affecting your performance all over the equipment life. So it's very important to take care from this. Next section is to have a cost justification, which is like cost benefit analysis, to be able to take financial decisions, to be able to make cost versus benefit for each task, for each tool, for each decision you are taking, and also to be able to calculate the net present value for any decision you are taking, and to know the future value of money that you are already having now. So this is very important tools to be used in order to be able to take decisions for the favor of delivering your value through your equipment selection and design. Another technique here, it's the implementation of the strategy itself. So you should have a lot of functions like maintenance, the execution, you should have maintenance program, you should have engineering team, you should have condition monitoring team, you should have planning and scheduling team, you should have resource management team, training team, financial team, and a lot of functions to be integrated together, cooperated together in order to deliver the value of the reliability or the equipment reliability to your organization. So all of this will be delivered here in this section. So the focus here is to implement what we have already evaluated and designed in the previous section. After that, we will come to section 7, which is a continuous improvement, to all the time review your performance, assess your key performance indicator, analyze deviation, and identify relevant best practices and implement continual process here. And also, there is very important process which is called project or preventive maintenance optimization, and we will detail it very much. And this is very important function, and you will find now a lot of people required in the market called preventive maintenance optimization engineer. We will provide in the detailed course clear guidelines for what is being done in this process. So this is for the 7 pillars, and now we are just delivering or proposing to you that we already having a detailed course detailing all of this without the Russian speech like what we have now. We are providing free study material in English and Arabic, videos, and a lot of things to be provided to all of you, in addition to solving hundreds of questions together, in addition to giving or solving full exam together, then taking full mock exam and live support through any channel like Telegram or WhatsApp till you pass your exam. And in case of any casualty, we are having money back guarantee, and for sure we are providing more than 1000 questions in addition to exams on each pillar and 7 full exams for the real exam. And for very limited time we are having a special discount for 20%. And for sure, if you need to apply with us, just scan this QR code and register with us, or directly contact us on these contact email and contact number, and you are welcome in any time. And see you in next section, inshallah.